Hi everyone, in this lesson we're looking at the tangent curve. So when we looked at the sine and the cosine curves, we had a maximum value of 1 and a minimum value of -1, but that's not going to be the case for the tangent curve. The tangent curve has a pattern that goes asymptote, -1, 0, +1, asymptote. So here's an asymptote. We're down here at -1, then we go to 0, then we're at +1, and then we have an asymptote. So that's generally how the tangent curve is going to work. The transformations of the tangent curve occur the same as they do with the sine and the cosine curve. A is the amplitude of the function, the distance from the center. Pi over b is the period of the function. Now remember, with sine and cosine, 2 pi over b is the period. If you look at the parent function here, let's just look at this center of this graph. Notice that we're going from -pi/2 to pi/2. So one full period completes in pi. Pi/2 plus pi/2 is pi. So the period is pi over b. C is still the phase shift or the horizontal translation, and D is the vertical translation, so moving it up or down. So let's take a look at some examples. It says sketch the graph of y equals tangent theta over 2. Now, students usually get really confused when they see something like theta over 2. Remember that we can just rewrite this as the tangent of 1/2 theta. Right now it becomes very easy to see what our b value is. This is the value of b. This is the value of a. Our amplitude is 1, and our number of cycles is b. So the first thing that we want to do is figure out what the period is. And the period can be found with the tangent curve by doing pi over b. So we have pi over 1/2. You're multiplying by the reciprocal because we're dividing by a fraction. So we get a period of 2 pi. Now remember, we said that the pattern is asymptote, -1, 0, +1, asymptote. Let's write that down. We haven't had any kind of horizontal translation. We're not moving it left or right, and we're not moving the function up or down. Remember now that this time our period is double that. It's not pi, it's 2 pi. So we're going from -pi to pi, because pi plus pi gives me 2 pi. So -pi to pi. And nothing else has changed. We're going to have an asymptote, then we're going to be at -1, then we're going to be at 0, and then we're going to be at +1. So let's sketch that in. Now we're being asked to sketch this function to 2 pi, so I'm going to continue sketching my curve. I have one period drawn in. I need to add pi plus 2 pi to get to the next period. Pi plus 2 pi is 3 pi. Halfway between pi and 3 pi is 2 pi. Just want to make a note because that's where I'm supposed to end my sketch. All right, so we're at -1, we're at 0, and we're at +1. We'll draw that in. And we only need our sketch to be included from 0 to 2 pi. So at this point, I'm just going to erase what happens before 0 and after 2 pi. All right, so that's what our sketch should look like for the tangent curve between 0 and 2 pi when we have a number of cycles at 1/2. All right, let's take a look at example 2. So it says, sketch the graph of 1 plus tangent x. So our amplitude is 1 because the value in front of tangent is 1. Our period is going to be pi over b, and b is 1. So let's just make a note. I'm going to rewrite this too. I'm going to rewrite this as tangent of x plus 1. So B is equal to 1, right? A is equal to 1. We have no horizontal translation. There's no phase shift. We're not going left or right because we don't have anything with our x value. But we do have this 1 on the outside, which means that our whole function is going to move up 1. So instead of it being asymptote -1, 0, 1 asymptote, it's going to be asymptote 0, 1, 2 asymptote. So let's write that down. And again, that's just because the entire function moved up 1. It's normally going to be -1, 0, and 1, but we moved everything up 1, so I just added 1 to each of those, and I got 0, 1, and 2. We don't have to worry about moving left or right. So let's start sketching our curve. Let's make a note that our period, of course, is pi over b, and that's going to be pi over 1, which is just pi. So we know we're at negative pi over 2 and pi over 2. And then we're just going to be adding pi to pi over 2 until we get to 2 pi. So we're going to be going from pi over 2 plus pi. Phase of the graph would begin at 3 pi over 2. 3 pi over 2 plus pi would give me 5 pi over 2. Center of that would be 4 pi over 2 or 2 pi. So right here is 2 pi. All right, let's sketch in our asymptotes. Our asymptotes are occurring at negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2. And our whole curve has moved to 0, 1, and 2. So I'm going to plot those points. 0, 1, and 2. 0, 1, and 2. 0, 1, and 2. Let's sketch those in. And we need to make a note that we only need to sketch from 0 to 2 pi. So if you want, you can just erase the parts of the graph now that aren't between 0 and 2 pi, or I think I'm just going to highlight them this time. So this is the part of the graph that I would include because I'm only going from 0 to 2 pi. Sometimes it's just helpful to just start sketching it and then go back and look at what your boundaries are and just either erase or highlight within those boundaries. All right, so that's it for example 2. Let's go to example 3. All right, we have a little bit more involved with example 3. Let's make a note. We have an amplitude of 3. So the distance from the center is 3. We have a value of b at 1 over 4. We have no phase shift because x isn't plus or minus a number. And we have no vertical translation because we don't have anything outside the function moving it up or down. So the center of the graph will be at 0. But because our amplitude is a, we're going to be having a point. We'll have a point at -3 and a point at 3. So let's write out what we think the pattern would be in this case. It's going to be asymptote. Then it's going to be -3, 0, 3, and asymptote. All right, our period is going to be pi over b. So it's going to be pi over a fourth, which is 4 pi. All right, so we're at -2 pi and 2 pi. All right, we're going to -3, 0, and +3. And we only need to draw the graph between 0 and 2 pi, so we don't need to draw anything further. I'm going to sketch in just this one cycle of the graph. And then I'll just highlight the part of the graph that is between 0 and 2 pi. And so we're done. Example 4, use technology to help you solve the following equations, round all values to the nearest hundredth. So we're going to use our calculator to find the intersection between the tangent of theta and 3. First thing we want to do when we open our calculator is make sure we're in radian mode. We're working in radians. So we're going to press mode, and I am in degree mode, so I want to highlight enter. Then we're going to go to y equals. We're going to enter the tangent, and we're going to enter the right side of the equation, which is 3. And we'll do zoom trig to look at this graph. Zoom number 7. And that gives us a good starting point. For that, we're being asked to solve this graph between 0 and 2 pi, so I'm going to go to Window, and I'm going to change my x values from 0 to 2 pi. And now I'll look at the graph. And we just want to see where is there an intersection between 0 and 2 pi. And if you notice, we've got 2 intersection points here. So we're going to go to second trace to get to calculate. Number 5. We'll move the little spider towards the first intersection point. Okay, we're near the first intersection point, so it says first curve, enter, second curve, enter, enter. So the first value is 1.25, rounded to the nearest hundredth, and then we'll do it again. Second trace, number 5. Move near the second intersection point. Just need to be closer to this intersection than to the other one. Hit enter, 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 and we get 4.39. Right, let's try the next one. Go back to the calculator, go to y equals. We're going to enter tangent 2 theta this time, 2x, and 5 minus x squared. I'm going to do zoom trig again. And this time we're being asked to look at the graph to find solutions between negative pi and pi. So let's go to Window. We're going to enter negative pi. And always use the pi button, don't round pi. Go to graph. Right now we have a better visual of what's happening between those boundaries. And then now if you notice, it looks like there's some intersections happening a little bit higher on the graph, and I can't really see them. So I want to go back to Window, and I want to pick a higher value for my y, positive part of my y-axis. So I'm just going to pick 10. I don't know, I'm just guessing, but let's see if that works. We'll go to graph. Hopefully we'll be able to see all the intersections. Okay, perfect. So we've got an intersection here, 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 and here. So we're going to have 4 solutions. So we have to do the calculate intersect 4 times. Move to the first intersection. I'm going to hit enter, 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 and we get a value of negative 0.90. Do it again, second trace, number 5. Move to the next intersection point, hit enter, 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 and we get a value of 0.68. Do it again, second trace, number 5. Move your spider again. Enter, enter, enter. We get a value of 1.98, and the last one, second trace, number 5. Enter, 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 and we get a value of 2.61. Okay, everyone, that's all I have for this lesson. Hope you enjoyed it. Have a great day.